Minasan, konnichiwa, Samurai Engineer desu. So let's resume, and we are now on module number 8 on our course review. So let us proceed. This topic is about Arduino, datasheet, and specifications. Let's immediately go to the problem number 1. So what is the difference between IDE and a compiler? Okay. A compiler executes the code while the IDE gives a graphical environment for writing the code. Letter B, the compiler links the code to the respective files and the IDE takes it from there. And letter C, the compiler and the IDE are the same thing. Letter D, the IDE executes the code while the compiler gives a graphical environment for writing the code. Okay? According to the primary definitions of a compiler and IDE, the job of debugging and executing a piece of code falls on the compiler, debugging and executing, while the job of the IDE is to provide an easy use environment for writing the code in the first place. So just to make it easy for us to write the program. So therefore, letter A. So number 2, what is the operating voltage of 80 MxE.08? So this is supposed to be capital letter, 80 MxE.08. A, 1.9 volts to 5 volts. B, 1.8 volts to 5.5 volts. Letter C, 1.1 volts to 5 volts. Letter D, 12 volts to 9 volts. So the operating voltage of 80 MxE.08 is 1.8 volts to 5.5 volts. Okay, so the answer is letter B. What will be the output of the following Arduino code? So the code has define X 10, okay, semicolon, void setup function, open brace, X is equal to 0, semicolon, serial dot begin, quantity 9600, semicolon, serial dot print, quantity X, semicolon, close brace, then void loop function, open brace, slash slash do nothing, close brace. Okay, so what do you think will be the output of this code? A, 0 by AB. Letter B, 0 by A. Letter C, 0. Letter D, error. Okay? In the above code, we have attempted to modify the value of X, which is here, X equal to 0. Okay? Which is initialized using the pre-processing directive define. We define X to be equal to 10. Now, we define X to equal to 0. Okay? So, which make its value unchangeable throughout the entire code. Thus, the compiler will throw an error because of this. This is global, supposed to be a global definition. Includes setup function and loop function. So we cannot change it because it is initialized globally, right? So error. So the answer is letter D. Number 4. What does the Arduino IDE search if it needs to find out the name of a type of Arduino board? So the IDE will search for A, Arduino.h, B, build.txt, C, boards.txt, D, build.core. The different types of Arduino boards, which are also commonly referred to as variants, are present in the boards.txt file. This is a particularly important file because it contains the different configuration information for different Arduino boards, like which compiler toolchain to execute on a particular variant. That's why it would search for boards.txt. So the answer would be letter C. So number 5, how many times does the setup function run on every startup of the Arduino system? A, 4, B, 5, C, 2, D, 1. So the setup function is used predominantly to configure the pins, variables, serial data, and others, and executed only once. So the answer is letter D, 1. Setup. So one setup only. And what will be the output in bytes of the following Arduino code? Void main, parenthesis, open brace, int a is equal to 0, semicolon, double D is equal to 10.21, semicolon, print f, parenthesis, double quotation, percent LU, comma, size of quantity A plus D, close parenthesis, semicolon, then close brace. Then, void loop function, open and close brace, nothing. Okay? What would be the output? Okay. So the output A is 10.21, B 8, C null, D 23. The size of int and double are 4 and 8 respectively. A is an integer variable, whereas D is a double variable. As you can see here, A, D, so 4 and 8. Okay? So therefore, the final result would be a double because this is a double, letter D. Okay? If you add integer plus double, it will become a double. Okay? Okay? In this case, in order to keep the precision, hence the output of the code is 8 bytes rather than 4 bytes. So the answer would be letter B. Okay? So number 7, what is the use of ESP8266 WiFi module? A, network provider. B, switches circuits. C, evaluates air pressure. D, monitors motion. So the ESP8266 Wi-Fi module is basically a network provider. So it is a module which helps you your connecting your microcontroller to any Wi-Fi networks in the vicinity. So that is the device that would search for the available Wi-Fi. Okay. So therefore, Arduino can be used to connect to Wi-Fi and use it for communication and, for example, IoT or Internet of Things. Okay. Number 8, what is the full form of EEPROM or EEPROM? A, electrically encoded programmable read-only memory. B, encrypted electronic programmable read-only memory. Letter C, electrically erasable programmable read-only memory. Letter D, electronic embedded programmable read-only memory. So the answer to this is letter C. Number 9, why is the Arduino Mega more viable solution when dealing with complex projects than compared with Arduino Uno? A, more flash memory on the Arduino Mega. Letter B, higher power rating on the Arduino Mega. Letter C, higher SRAM on the Arduino Mega. Letter D, more number of GPIO pins on Arduino Mega. So Arduino Uno has 14 pins for I/O, of which 6 supports PWM, while Arduino Mega has 54 pins for I/O, of which 14 supports PWM. Moreover, the Arduino Mega uses ATmega2560 microcontroller, which has an SRAM of 4K bytes and a flash memory of 256 bytes, whereas the Arduino Uno is only supported by ATmega328P microcontroller, SRAM of only 2K bytes, flash memory of a mere 32K bytes. Okay? So, therefore, more I/O. Okay? Okay, so higher SRAM is okay. Higher flash memory. So therefore, the answer is letter D. So then number 10, why does every compilation have a source code in Arduino? Check for previous compilation. So after compiling, then you have your new project, then compile the next time. Then why? It will check on the previous one. A, to copy the previously generated .o files. B, to relocate the previously generated .o files. C, to delete the previously generated .o files. D, to use the previously generated .o files. So the answer to this is during compilation process, the Arduino compiler, before compilation, searches for previously generated .o files in the directory. Why? To make the compilation process faster, and in some cases, this reduces the redundancy of compiling the same parts of the code repeatedly. So, if it able to find files that are similar, so it will not recompile. So those parts only that not yet compiled will be compiled this time. So it would work faster. Okay, so by this, again, this is Dr. AP, preaching engineering for nations.